Hello everyone, in this video I will go through the basics of selection based programming in Snap. So selection programming, we have already seen this in Microsoft Excel where we use the if function. The if function was basically the if else selection based programming, but in Snap programming we have two options. First of all, we have the basic if construct in which we have just a single choice. If the condition is satisfied, then we will use the block that we provide. If the condition is false, we will skip the block. So normally when we are doing sequential programming in Snap, we follow a step-by-step procedure. We follow a top to down approach. And when we have the selection based programming, the if construct or the if else blocks, it will cause branches in our flow of the algorithm. So if you are going top to down, when we have a condition which is indicated by a diamond shape, this condition basically indicates that there will be branches in our algorithm. So if the condition is true, I will follow the same path, I will include this block, but if the condition is false, I will skip this part and then move ahead. So as an example, we have this very simple program that is to input the grade and the number of absents of a student, and then if the absents are greater than 0, we will reduce the grade according to the number of absents. If the numbers are 0, in that case we will not reduce any grade. In that case we will simply update the grade and directly show the result. So this block, you can easily create this in Snap programming by using the Control tab to take out the green flag block, and then from the variables tab I can create two variables. One is for the grade and another variable that is for the absents. So I have two variables here. So what I will do is I will first get the input of these variables. I will use the ask block from the sensing tab and I will ask to enter the grade. You can display any message you want. That message will be displayed on the stage area, and the answer that you drag out, you will assign the answer. You will use the set block from the variables tab to assign the answer to the grade variable. So the grade will receive that answer, whatever the user types on the screen. After that, I can duplicate the ask block to get the input for the absents. So once I receive the input for the absents, I will assign those absents to the variable absent. So I will display the message first to enter the number of absents, and then I will assign the absents the answer that we will receive. Once I have received the input, this is where our selection part begins, where we will check. If the absents are greater than 0, in that case I will reduce the grade. Otherwise, I will keep the same grade and display it on the screen. So here I will go to the Control tab, and in the Control tab, if you scroll down, there is the if block. You can drag it outside. So this first part of the block, this is where you provide the condition, which is an inequality operation that will result in an answer which is true or false. So if the answer is true, I will include whatever I put inside this small block underneath the condition. If the answer to the condition is false, the block inside the if will be skipped. So for the inequality operations, we can go to the operators tab, and the inequality comparisons are indicated by these hexagon shapes here. So here I can check using the greater hexagon block. I can check here using the variables block. I can put that if the absents are greater than 0, in that case I will reduce the value of grade. So I will say that set grade to grade minus the absent. So the current value of grade will be reduced by the number of absents. And then once we have decided either we will reduce the absents or not, once we get out of the if condition, I can use the looks block to display a message, and to join the text with a variable I will use the join block from the operators tab and place it inside the hello block. And here I can display the message that okay, the updated grade is equal to, in the second box I can provide the grade variable here, and then using the control tab we can stop the script. We can stop this script. So that is your grade program. So here if I enter the grade, let's say 75, and then enter the absents, let's say 5, in that case the updated grade will be 70. So this is your if block. Similarly, we have if else block where we are given two options. One if the condition is true, the second if the condition is false. So if the condition is true, I will use the first branch here. If the condition is false, I will use the second branch. But both of them will not be included in my algorithm. At a time, only one of them will be used. The path will depend on the condition, on the inequality. If the condition is true, I will follow this path. If the condition is false, I will follow the other path. So that is your if else blocks. So here we have a very simple example that will check if the student is pass or fail. This one is very simple. There is no need to implement this one. So here what I will do is I will ask to enter the grade, and using the if else block I will check if the grade is greater than 60, I will display the message pass, or else I will display the message fail. So this program you should be able to try this. Here I will check the values of the variables and how they are changing depending on the condition. So let us see now. So I have two block of codes here, so I can check them one by one. In the first one we have two variables, so we can think of them like two boxes, A and B. A is set to 10, so A contains 10, B contains 2, and then we have a condition, the simple if block. It says if A is less than 11, so A right now is 10, so 10 is indeed less than 11, so that means set B to 5. So B value will change to 5. And then when I get out of the if construct, there is set A to A plus B. So A is 10, B is 5, 10 plus 5, 15 will be the new value of the variable A. So these will be the final values of the variables A and B after the first block. Then let's have a look at the second one. So if I look at the second block of code here, we have again here two variables A and B. So think of them like two boxes. So A is set to 11. So A is 11, B is set to 2. And now here we have if else block, not the simple if. So that means if the condition is true, I will use the first block. If it is false, I will use the second block. So A less than 11, 11 is not less than 11. That means the condition is false. I will jump to the else area here. And here it says set A to A plus B. So A is 11, B is 2. So the new value of A will be 13. So A will become 13. And then after getting out of the if else block, there is another set block that says set B to A plus B. So B will become 13 plus 2, 15. So that's how the values will appear. So A will be 15 and B will be 5 in the first block. In the second example, A will be 13, B will be 15. In the quiz, I can ask you questions similar to this one. Another simple example here is for the if else to check if a number is even or odd. So simply to check if a number is even or odd, we need to check if it is divisible by 2. We have to check if the number is divisible by 2. What that basically means is to check if the remainder when a number is divided by 2, the remainder when a number is divided by 2 should be 0, should be 0 for even numbers, should be 0 for even numbers. So our algorithm, it's very simple here. We will have the start point, and then we will need just one variable, because our output is to just display a message, not to calculate some results, just to display a message. So I will just declare one variable, that is the input number. Let's call it, declare the variable num. So once I have that variable, I will input the variable num. When input, we basically ask the user to enter the number. We ask the user to enter the number, and whatever answer we receive, we give that answer to the variable num. So after receiving the input, we will use if-else conditions. So in the if part, I will write some condition, and if this condition is true, I will display the message that the number is even. So I will display the message that the number is even. And if the condition is false, in that case, that's where the else part comes. Else means when the condition is false, in that case I will display the message the number is odd, and after that I can stop my script. So this is how the program should work. The only thing left here is the condition. So how to check if a number is even or odd? So what I want to do is just to make sure that the number is divisible by 2. That means I want to check if the remainder when we divide the number by 2 is 0 or not. So to do that, we can use the comparison operator. Which is available in Snap programming. So here you can save this one first. So let me save this first. You can call it ex1. You can save it in the computer, on the desktop, a new folder that is snap2 minus your ID, whatever the ID is. So here you can save this one, and let me do a next project. So here the even odd program once again. So I use the green flag, and then I create variable called num, which is for the input number, and then we will use the sensing tab to ask for the number. So I will ask enter a number. Whatever answer I receive, I will set the number to the answer. And once I have received the input, I will go to the control tab and take out the if-else block. And here I have two options. From the looks, if the condition is true, I will display the message that the number is even. Else I can display the message that the number is odd, and then at the end of my if-else block I will stop the script. The only thing left here is the condition. So here in the operators we have an equality comparison block. It will compare left and right sides. So what I want to do is I want to check if the number is even. That means the remainder when divided by 2 should be equal to 0. So my right side I will put 0. The left side should be the remainder of the number when divided by 2. For that we have used the mod operator just like last time, that is mod. will calculate the remainder when the number is divided by 2. So number mod 2 will give you the remainder when a number is divided by 2. So if that is equal to 0 and the right side is also 0, if that is true, in that case I will say the number is even, otherwise I will say the number is odd. So if I run this program here, enter a number, if I enter 15, it says the number is odd. If I run this program again and I enter the number, let's say 9958, that's an even number. So that's how you can check if a number is even or odd using the if else conditions. You can call this ex2, save it in your computer, and that is your basic if else conditions. The blocks are also given here as well. There's another way you can solve this. So we have seen the basic inequality operations, for example the greater than, less than, or equality comparison, and there our inputs are real numbers, or they can be whole numbers, or basically any type of equation that will give me a numbered answer. For example, if I have an input 6 greater than 11, so the inputs here are whole numbers. The main property of these inequality operations is that whatever the inputs are, the answer is always in the form of true or false. Now, what are logical operators? In logical operators, or the Boolean operators they are also called, their property is that not only the output but the inputs are also in the form of true or false. As an example, we have the operators like AND operation or the OR operator. So these operators, they have two inputs and both the inputs are also in the form of true or false. For example, if I have two inputs A and B and they can have only two logical values, that is true or false, then the total possible values we can have are 4. That is, both the inputs are false, one input is false, the second one is true, one input is true, the second one is false, or both of them are true. So these logical operators, for example A and B. So how these logical operators will work? The AND operation basically works in such a way that the output is true only when both the inputs are true. You can think of AND operation like multiplication. If false is indicated by a 0, so in the input, if there is false anywhere, here or here or here, the output will be false. The output will be 0. So the first three possibilities where both inputs are false or one of the input is false, the output will be false. The AND operation will give you a true output only when both the inputs are true. Then the OR operation, we have another one that is called A or B. The A or B operation will give you a true answer if any single input is true. So when both inputs are false, A and B are false, the output will be false. When one of the input is true, the output will be true also. So when the third input, when one input is true, the output will also be true. And when both inputs are true, the output is also true. You can think of this a little bit similar to addition. So these are the AND and OR operations. We have another one that is called the NOT operation. NOT operation will do the opposite of whatever the input operation is. If I calculate, for example, NOT of true, the answer will be false. If I do that, NOT of x less than 5, that is same as saying x greater equal to 5. So because the opposite of less than is greater equal. So the not is the opposite operation that we can also use in equations. And then we have directly the true false operators which are available in Snap. We can manually set the condition true or false. So based on that, we have some examples here. I will go through these examples that will help you in understanding how these variables are working. So here we have a variable a which is set to the value 6, variable b which is set to the value 9, and a variable c which is set to the value 14, and then we have a flag whose value is basically true. So based on that, we will evaluate these conditions. So the first one, we will see which block is in the front. The block that is a is equal to 7 is in the front. So I will compare 6. Is it equal to 7? The answer will be false. And when I take the not of false will become true. And true and the flag here is also true. So true and true will give me this left side as true answer. So when one side of the OR operation is true, it doesn't matter what the right side is. You don't need to calculate that. The answer will be true. So for the first example, the answer will be true. In the second case, C is equal to A plus B or not of flag. So now I will calculate this part first. A plus B. A plus B is 9 plus 6, which is 15. Is it equal to C? C is 14. No, the answer is false. Or not of flag. Not of flag, which is true, that will become false. So false or false will give me the answer false. Then in the third one, once again I will check which one is in the front. So here we see B less than 12. 9, is it less than 12? Yes, true. No need to check this part. So when not of true, this will give me the answer false. And false and with anything, true or false, the answer will be false. So the overall answer will be false. So you notice that in these long equations, you don't need to check the whole equation. As soon as you understand the logic, you satisfy a certain condition, you don't need to check the remaining part. Here also, for example, floor of C divided by A. So 14 divided by 6. 14 divided by 6, first of all, it will be equal to 2.33, something like that. So when I take its floor, it will remove the decimal part and I will get the answer 2. So 2, I am checking it. Is it equal to the round of C divided by A minus 0.5? So 2.334, if I subtract minus 0.5 from that, and then take the round, what will happen? So 2.334 minus 0.5, it will give me 1.834. And when I take its round, it will also give me the answer 2. So yes, the answer of the fourth condition will be true. This can be generalized also. The generalization here is that floor of any real number is basically equal to the round of the number minus 0.5. You can check it. For example, if the number is 3.8, then the floor of 3.8 will basically give me 3, which is same as 3.8 minus 0.5, that will give me 3.3, and when I take the round, it will also give me 3. So that's also satisfied when the number is 3.8. Similarly, if the number is, let's say, 3.2, floor of 3.2 will give me again 2, and 3.2 minus 0.5 will basically give me 2.7, and when I take the round, 2.7 rounded to the closest integer will also give me 3. So this is a general equation you can always use. Floor of any number is same as round of the number minus 0.5. Then the fifth one, we have not of a less than b. So a less than b, let me check. So here 6, is it less than 9? Yes, it is true. When I take the not, it will give me false. So the left side I'm getting a false or a 0. And on the right side, let's say a greater than b. 6 is not greater than 9, so this is false. Or a equal to b. 6 is not equal to 9 also. This is also false. False or false will give me the answer false. And false, is it equal to false on the left side? Yes. So the overall answer will be true. So that is your fifth condition comparison. Then it says set b to a greater than 4 plus c less than 15. So a greater than 4, 6, is it greater than 4? Yes, true. True is also indicated by a 1. So that means 1 plus c less than 15. 14, is it less than 15? Yes, that is true, which means the answer is 1. So 1 plus 1, the value of b will be set to, the value of b will be set to 2. So b will be basically equal to here 2. Now, in the next step, a less than b less than 3. So here a is 6, b is 9. So 6 less than 9, this is true. That means it is 1. So 1, is it less than 3? Yes. So the answer will be true. For the next one, b greater than a. So b is 9. Is it greater than 6? Yes. 1, is it greater than 3? True. That means 1, is it greater than 3? No. So the overall answer will be false.